Hey guys, Mrs. Young here. Time to go over our Chapter 5 Exploring Space Study Guide for our upcoming test. So, in this interpreting the table, you are going to need to know the difference between the orbiter, the lander, the flyby, and what was accomplished. So, let's start at the top there. So, the uncrewed, remember, an uncrewed is going to be unmanned, no humans on there. Cassini, that was the first orbiter sent to Saturn. So we're going to highlight that. First orbiter sent to Saturn. How I'm going to have you remember this is Cassini. Do you see all those S's in Cassini? And then we think of Saturn starts with an S. That's how we're going to put those two missions together. Okay, so it studied Titan, the largest moon, found geysers on another moon, studied the rings. There were 19 countries involved with this. It wasn't just a U.S. venture. Okay, so the next is an uncrewed lander. Remember, with an orbiter, let's go back to that. An orbiter is going to just simply orbit that particular planet or moon. It's going to slow down, get pulled into its gravitational pull, and just orbit round and round and round until they run out of fuel, sending radio waves back to Earth. Okay, a lander, right, is actually going to land. So the one we're going to put there is Phoenix. I don't have any tricks for you on this one. Analyze the Martian surface, looking for evidence of water. A flyby, remember a flyby is going to be just that. It's just simply flying by. It's not getting stuck in the orbit. It's not landing. It is a flyby. Voyager 1 explored Jupiter and Saturn and will eventually enter interstellar space. Those are all three of those are uncrewed. So then we have our first crewed mission. With a crewed mission, it means there's going to be people on board. So Apollo, it was a challenge by President Kennedy in 1961 to put a man on the moon by the end of the decade. Because remember, the first satellite, Sputnik, and the first man to orbit Earth were both done by Soviet Union. So this is a big, huge space race, late 50s, early 60s. And so President Kennedy said, hey, you know what? Let's be the first one to get a man on the moon. So it's a series of space missions designed to go to the moon. Apollo 11 was the first to land on the moon, 1969. Alrighty, crewed orbiter, back to an orbiter. Unmanned, just simply goes round and round. So we have a lunar reconnaissance. What they're going to do is they're going to be looking for the best place for a future lunar outpost. So where are we going to set up shop? So lunar reconnaissance. It's a tough word to say. All right. So then here we have this section where you had this word bank, this large word bank, and you need to find a place to put all of these words. Okay, so a space probe is an uncrewed spacecraft sent from Earth to explore objects in space. So unmanned, it's going to go out into space. It's either going to be an orbiter, a flyby, or a lander, and it is not designed to come back. Okay, a refracting telescope uses a convex lens to gather and concentrate light from objects in space. A rocket lifts people and equipment into space by ejecting exhaust from one end. We created our little rockets with the Alka-Seltzer and the film cartridges. Okay, a dwarf planet is a round body that orbits the sun but is not massive enough to clear away other objects in its orbit. Pluto was once considered an outer planet but has now been demoted to a dwarf planet. A space shuttle is a reusable spacecraft. Reusable. Not just one and done, that will transport people and materials to and from space, mostly to and from the International Space Station. A lander is going to touch down on a planet's surface and sometimes release a robotic rover, like a little dune buggy. A reflecting telescope has a curved mirror. Remember, we can see our reflection in a mirror, so you're going to remember to put those two together. A reflecting telescope uses a curved mirror to gather and concentrate light from objects in space. So both the refracting and the reflecting, the purpose is to, get that light, concentrate that light in so that we can see. Okay, ceramic material developed for space shuttles is also used to make orthodontic braces. Isn't that interesting? So it's on the outside, like to protect like the heat. Okay, the cooler stars can be observed in the radio wave part of the EM spectrum. So that is a way that we're able to tell the type of star is by looking at the EM spectrum. The hot stars are going to be up in that high frequency, like in the gamma X-ray range, and the cooler are going to be down with the longer wavelength, lower frequency radio. Okay, a flyby is going to do just that. It's just going to fly by and collect data, send data as it passes by a planet, but it does not land and it does not orbit. It just flies by, just like its name suggests. The United States and 15 other nations began building the International Space Station. Okay, international, because there's lots of different nations doing that. So United States and 15. NASA began operating a reusable space shuttle to transport people and material to and from space. A space exploration vehicle that travels through space and then uses a rocket to slow down when it reaches the planet it is meant to study is known as an orbiter. So it's going to slow down until it can get caught in the gravitational pull of that particular planet, and then round and round its orbit it goes. If something that is living originated outside Earth, it's called extraterrestrial life. Astrobiology is the study of life in the universe, including life on Earth, and the possibility of extraterrestrial life. What I want you to remember and put together that is that astrobiology is not the study of extraterrestrial life. Astrobiology is the study of life in the universe, including life on Earth, and the possibility of extraterrestrial life. Okay, so then we get to this section where we have first of many. So artificial satellite to orbit Earth was Sputnik 1957 from the former Soviet Union. Optical space telescope was the Hubble Space Telescope in 1990. People to walk on the moon, Neil Armstrong and Buzz Aldrin, Apollo 11. Planets studied by a probe, the first was Mariner 2, traveling to Venus in 1962. Destinations for future human space travel, there are two places, and it is our moon and then Mars. What medical applications have their roots in the space program? This one you're going to need to be able to write out. This is part of the short answer. I'll give you that little hint. Okay, what medical application have their roots in the space program? Artificial limbs, infrared ear thermometer, robotic surgery, and orthodontic braces. How is the electromagnetic spectrum used by scientists to study stars? Most stars emit energy in all wavelengths. How much of each wavelength they emit depends on the temperature. Hot stars emit mostly shorter wave with higher energy, such as X-ray, gamma, ultraviolet. Cooler stars emit mostly longer waves with lower energy, such as infrared and radio. Our star is a medium temperature range and emits most of its energy as visible light. That bodes well for us, seeing as that we need visible light to see. So what type of EM wave is collected by the Hubble space? That is visible light. What type of EM waves are able to reach the surface of the Earth? Okay, so which ones can? Visible light can, radio can, and some microwaves can. So that is why our Earth-based telescopes collect visible light and collect radio waves, because those are the EM waves that we can detect after it going through our atmosphere. EM waves are able to transfer energy through what medium? Well, we've had this question for several chapters now, so we know that EM waves can go through solid liquid gases as well as empty space, vacuum, outer space. How are planets and moons different from stars? Planets and moons do not make their own energy, so they do not emit light. The planets and the moon simply reflect the light from the sun. How does Earth's atmosphere interfere with the operation of telescopes? Earth's atmosphere absorbs some of the EM radiation. Only visible light, radio, and some microwaves reach Earth's surface. Telescopes on Earth can only collect EM waves that are not absorbed by Earth's atmosphere. And the Earth's atmosphere is also going to cause some distortion. We'll talk about that in a moment when we talk about stars. Why do space telescopes collect more kinds of data than telescopes on Earth? Well, telescopes in space collect wavelengths of all, can collect energy. Oop, that didn't work well, did it? Okay, collect all of the wavelengths, including those that Earth's atmosphere would absorb. The sky is darker in space, and there's no weather. So think about if you are going out on a cloudy day looking out at the stars at night, you're not going to be able to see them. But if you get outside of our atmosphere, we're going to be able to collect all of those wavelengths. It's much darker in space. There is no weather that's getting in the way. So we're going to go ahead and finish up this. We'll finish up the rest in the next video.